Paper 1, question 26. This could get quite messy in terms of how I'm going to write it out, so bear with me. Faiza has 10 coins in a bag. There are 3 £1 coins and 7 50p coins. Faiza takes at random 3 coins from the bag. Work out the probability that she takes exactly £2.50. Okay. Now, key things I'm going to mention here and link to the colours I've got are these 3 coins that are being removed from the bag. So I've created a probability tree diagram where at the beginning nothing's happened, you've not done anything yet. These black branches are the 2 choices that could happen. On that first coin you take out, one of those branches represents taking out a £1 coin, one of them represents taking out 50p, and in a minute we'll assign probabilities to that. From there, when you get to these sort of knuckle bits here, or branches of the tree, you then enter the second phase of this process where you take out the second coin at random. Now, it's important to make sure that you draw these down in some way, and a probability tree diagram I would highly recommend for that. Because when you take out the second coin, you don't have the same situation that you had before because there's 1 coin less. If it says something in here about replacing the coin, it might make the question easier, but it doesn't. You're taking all 3 out, so you're taking 1 out, not replacing it, taking a second one out, which in this case is the blue branches, not replacing it. And then when you take that third coin out, in red here, is the third situation that happens, alright? So just bear with me, in terms of the probabilities you get here, they're all representative of that moment. So once you've taken the coin out, you have a different total. Once you've taken 2 coins out, you have a different total. And hopefully you're already thinking about what those might be. In terms of all these branches, just to make a note, going up the way will always be taking out a £1 coin, and going down the way will always be taking out a 50p coin. So at least when you look at this, it's got some form of consistency. So going up the way here, if I take out one of those £1 coins, there are 3 of them, I'm going to have 3 tenths. 3 out of 10 is going to be my probability. 3 £1 coins, 10 coins in total. Conversely, with 50p coins, there were 7 of them, and the probability of taking one of them out first is 7 out of 10. Now, it's important to note that when you branch off like this, your 2 probabilities should add up to 1, because they describe, it doesn't matter if there's 2 branches or 3 or 4, in that one moment, those branches describe all the possible outcomes. So in this case, you're taking out a £1 coin or a 50p, you're not sticking your hand in and then coming out empty-handed. You will have one of those. So hopefully you can see straight away, they'll add up to 1. Second phase here, we've taken out a £1 coin, so there's 1 less, which will instantly make both of these fractions out of 9. Same with the removal of the 50p. Our total is going to be out of 9 for all of these, because there's 1 coin less. We took a £1 coin out here, which means there's only 2 of them left. Alright? Whereas you're still left with all 7 of the 50p pieces. Going down this way, you took out a 50p, so there are only 6 50p pieces left, whereas in total you still have 3 £1 coins. Okay? Finally, the probabilities for these branches, again, going up the way is as if you're taking out a £1 coin, going down the way is as if you're taking out 50p. Although I labelled these here, it's not worth me labelling all this, otherwise it'll get very congested. Feel free to be making a note of this as you're going along. If I have taken out a £1 coin and a £1 coin already, if I take out the last £1 coin, there's only 1 of them, and there are only 8 coins left, I end up with an 8th. Whereas, if I've taken out 2 £1 coins already, I've not removed any of the 50p's, 7 of them remain, so 7/8 is the probability there, okay? I've taken a £1 coin, I've taken a 50p, both cases here we still have 8 coins left. But in this one there are still 2 £1 coins left, and in this one there are 6 50p's left. Down here, taking a 50p out, taking a £1 coin out, it's exactly the same situation as at this knuckle here. It's just the order is different. So I again have 2/8 as the probability of removing a £1 coin, and 6/8 as removing the 50p piece. For the last one, I've taken 2 50p's out, so there should only be 5 remaining. So 5 out of 8 is your probability for that. There are still all 3 £1 coins still remain. So 3/8. So even a quick glance there, 3/8 and 5/8 add up to 1, 2/8 and 6/8, 2/8 and 6/8, 1 8 and 7 8, all of those together add up to 1. Same with here, 2 9, 7 9, 3 9, 6 9. Now, every end point here, 8 in total, represent a different outcome of the experiment, a different number of coins, a combination of coins that have been removed. Now, the way that this has worked out, you will have some ends that yield the same outcome. So, for example, there may only be one way of removing 3 £1 coins, which is here, and there may only be one way of removing 50p coins, which is here, but there are different combinations in between of having £2 coins and a 50p, and two 50p's and a £1 coin. Now you need to figure out which one you're interested in, and that's given to you subtly by the fact that you're looking to figure out the probability that £2.50 is removed. Now the only way you can get £2.50 is you're looking for when 2 £1 coins and 1 50p piece have been removed. As far as this diagram goes, that means that we are interested in this outcome. We've got £1, £1, 50p. We are interested in this outcome, which goes £1, 50p, £1, and we are interested in that outcome, which goes 50p, £1, £1. I'm hoping you can see that without my labellings in between, but those three outcomes are what we're interested in. If you want to know the probability of each of these outcomes, you basically go on a journey of the probability of this was 3/10, then you have a probability of 2/9, then you have a probability of 7/8, and you compound them up. So the chances of all three of these things happening, chances of three different probabilities all happening at the same time, you multiply them all together. So for this one, I'm going to have 3/10 times 2/9 times 7/8. For this one, I'm going to have 3/10 times 7/9 times 2/8. And this one, I'm going to have 7/10 times 3/9 times 2/8. Okay? And I'll take that to the next page. We no longer need that anymore. Just rewind if you want to have a look at that. I'm going to go with the probabilities of it. That top one we had was 3/10 times 2/9 times 7/8. Put that in brackets for now. I don't really need to, but that's the first outcome, the probability of the first outcome. The probability of the second outcome was 3/10 times 7/9 times 2/8. And the probability of the third one, which I'm going to put here, I'll explain why in a minute. The probability of that one was 7/10 times 3/9 times 3/9 times 2/8. Okay? Now you're asked, work out the probability that she takes exactly £2.50. There are three possible ways to do that, so you add all these probabilities up, because this is doing it in one way, which the order of the tree stipulates. This one is £1, 50p. This one is £1, 50p, £. This one is 50p, £, So there are three different ways in which you can get £2.50. So if you multiply these probabilities together for the first instance, the second instance, and the third instance, and add them together, you're going to get the total probability of getting £2.50. Now there are ways in which you can simplify fractions here and go lower. You've got a 3 above a 9 here, which can cancel to give you a third, because the tops and bottoms are all being multiplied together. We have a 2 over 10 to give us a fifth, and nothing else is going to cancel there. 3 over 9 again for a third, 2 over 10 again for the fifth, and in the last one, we've got 3 over 9 here to give us a third. We've got 2 over 8 to give us a quarter. So I can make life easier for us there by doing that. Then all you have to do is multiply the resulting numbers on the tops and bottoms of each of these combinations of multiples. 1 times 1 times 7, 5 times 3 times 8, 120. Then we add here 1 times 7 times 1, 5 times 3 times 8 again, and just look at this, 7 times 1 times 1, 10 times 3 times 4, okay, that one's different. But the first two are exactly the same looking. This one I have 7 over, what would you know, 10 times 3 times 4, it still gives you 120. And thinking about logically, of course it makes sense that they're all the same, because the outcome is the same. So how you got there, the journey you took didn't matter. The 3 coins that you wanted, the £1 coin, the £1 coin, and the 50p, all happened. So you've got 3 similar probabilities here. Add them together, 21 over 120 is your probability. That can be simplified, although you won't lose any marks if you don't. 7 over 40 is your probability that you will remove £2.50 by taking 3 coins at random.